Design a slider crank mechanism with a time ratio of Q equal to 1.25, stroke delta R4 equal to 2.75 inches, and time per cycle of T equal to 0.6 seconds. Part A. Use the analytical method to determine the appropriate length L2, L3, offset distance L1 if any, and the crank speed in RPM. Part B. Use a compass and sketch your design in the fully retracted and fully extended positions. Part C. Identify the imbalance angle of your drawing. First, we will write down the known quantities of time ratio Q, the stroke delta R, and the cycle time T cycle. In order to find the lengths of the links, we must first find the imbalance angle beta. Beta can be found using this equation. Beta equals 180 times Q minus 1 over Q plus 1. We can also go ahead and find the crank speed, omega, and RPM using this equation. Omega equals 2 pi over delta T. To continue solving the problem, you must choose an arbitrary alpha 2 angle. In this case, we will choose alpha 2 equal to 30 degrees. Using alpha 2 and beta, we can find alpha 1 using the following. Alpha 1 equals alpha 2 minus beta. Now that we have the angles, we can find the length of the links. Length 2 can be found using this formula. L2 equals sine of alpha 2 minus sine of alpha 2 minus beta over 2 sine of beta times delta R4. Similarly, length 3 can be found using this equation. L3 equals sine of alpha 2 plus sine of alpha 2 minus beta over 2 sine of beta times delta R4. Finally, L1, the offset distance, can be found using this final equation. L1 is equal to L3 minus L2 times sine of alpha 2. After finding all of the values, we can draw the diagram. Using a compass and a ruler, the design can be drawn to scale. The fully extended position is when links 2 and 3 are lined up to put C at a maximum distance away from point A, and the fully retracted position is when links 2 and 3 are lined up to put C at its minimum distance away from point A. The imbalance angle beta is the angle between links B and C in the fully extended and fully retracted positions. This drawing represents the desired slider crank design.